As always, I'm going to start with a ball, my favorite yellow ball. Okay, so now let's start with something realistic. Let's say this ball, okay, we have this ball on, let's say on the floor, okay, this is the floor in the room, and I give it a kick, okay, I give it a kick, so a kick, and the ball will start rolling, okay, the ball rolls. Let's try and imagine what happens. The ball rolls, and it goes, and then it slows down and it stops. Of course, this is what we expect. What else can we expect? The ball has to stop. Now, right. But let's now imagine, okay, that we have a floor that is quite oily. Let's say I've dropped some oil. All right, I've dropped some oil on the floor. So there's this layer of oil on the floor. It's really slippery. If I try to walk, I will slip and I will fall down. Right? If I now kick my ball again, assuming that I don't fall down when I do that, the ball will start rolling again. Now this time, because the floor is so slippery, you would expect that the ball would not stop so quickly. It would keep going. It might keep sliding, rolling on the floor for a lot longer before it stops. Maybe on its own or when it hits a wall. Right. So we have some idea why there's this difference, because we know about friction. Okay, there's friction from the floor, and this friction gives a force that resists the motion of the ball. Okay, this friction resists the motion of the ball, and that's why the ball slows down. But if we have some water or oil on the ground, all right, maybe there's some layer of oil on the ground, it's really slippery, and the effect of this is that it removes the friction. Okay, the oil removes or reduces the friction, so that the resisting force will be a lot smaller, so that the ball can now go a lot further. So that's how we might understand a ball moving along, rolling along the floor, or in fact any object. Okay, any object that's moving. We expect that it would eventually slow down and stop, unless you keep pushing it, or unless you have a car and an engine moving it. On its own, it will just stop. Now, but in Newton's first law is about what happens if there is no friction. Okay, if there is no friction, what happens to the ball? Now, this is often difficult to imagine, because there's always friction, right? Wherever we go on Earth, almost anyway. So, but let's just suspend our belief or disbelief, and let's imagine what happens if there's actually no friction by some magic or some trick. So if there's no friction at all, this time, okay, let's imagine I've perfectly smooth, it's not good, it's a perfectly smooth floor, very smooth floor, and I have the ball again on the floor. Now this time, if I give the ball the same kick, the ball will start sliding. Alright, start sliding. It just keep going and going and going, because there's no friction to stop it, so that it just won't stop. Alright, you'll keep going in the same velocity, same speed, same direction. Okay, and until maybe it hit the wall, or hit a stone or rock or a tree. So that's the kind of thing that could happen, and it's not that unlikely. I mean, we can have a really smooth and oily floor, or we can have, say, the ball on very slippery ice. okay, then it will really go for a long way. Now there is another situation, of course, where this can happen, and that's if the ball is in outer space when there is nothing to stop it. So this is what Newton's first law is about. Okay, basically, Newton's first law says that okay, let me write this down. Newton's first law. Right, basically, it says that an object or a body, it will just keep going in a straight line and at the same speed. Okay, body, right, will move at the same speed and direction. All right, you just keep going. All right, you just keep going and going non-stop unless there is a force. Unless there is a force acting on it. Unless there is a force acting on it. So that's the idea. It will just keep going unless you have a force to either stop it or maybe push it sideways so that it changes direction. Okay, if you don't do that, this is what you'll do. All right, always going at the same speed, same direction.